So, and you can join it since there's only one extra person here. What's your name? And where are you from and what do you do?
I'm Cindy Schreiber from Farnsworth Aerospace.
Oh, yeah.
Actually,
And then,
colleagues, David,
yeah.
Kidwin, but I thought,
Yeah, yeah.
I know David.
David was great. So you, what do you teach? What is your?
Actually, I was a former sixth grade teacher, but now I do the aerospace engineering specialist, so I help support that.
Help support that.
I do a little bit of everything, so, but I do teach like robotics
Okay.
after school, so and then after.
Very neat.
So I thought I'd just learn a little bit more what David was doing.
David was great. I wanted to get him to come to the Wind Senators to like be an expert at this, like bring him to the training for the week, but has a busy summer.
Yeah, he's got a busy summer.
We do our master training in Portland, August 4th through 10, and then we have funding in Minnesota to send a Minnesota teacher to Portland. So we try to get the ones who sort of show up and do lots of really cool things, and then get them there. He was interested. I told him he had till sort of the end of the month to sort of think it over. But it's a sort of a time for teachers, you know, where it's like you're totally insane trying to close out the year. So, well, I would do this, even though. So, one of the things we start to lead with is that. So, for people who might be online, my name is Mike Arquin. I'm the director of the Kidwin Project, director-founder, and I'm going to give a presentation about. The Kidwin Challenge and the Renewable Energy Challenge in Minnesota, sort of a outgrowth of that, or a version of that we do here in the state as well. And sort of one of the reasons we do this is that 50%, less than 50% of Americans can name a renewable energy source, which is a fairly astounding statistic to me in a lot of ways, that we would even know. They can't even tell you biogas or solar or wind. They don't even know those names, let alone how they work and things like that. So that means there's an opportunity for us to do lots of work, especially considering that, I don't know how many of you are up in the news, but we just passed a very significant milestone in terms of this number. Anybody heard of what that number means? Oh, okay. So we just, for the first time ever, exceeded 400 parts per million of carbon dioxide in the atmosphere. Last time we hit this number was 10 million years ago, and there were no humans on the planet, and the Arctic was 16 degrees centigrade warmer. So fairly, I would say, pressing problems in the space in terms of creativity needed and energy and things like that. So that is sort of why. Another reason why we do it, there was a great study done by a group in this is a couple years ago, and they brought a bunch of adults in the room and said, draw a picture of what the world looks like after fossil fuels are depleted, which is a little bit of a weird thing to do, but just pretend there's no more fossil fuels. How are we getting around and doing things? And you have to date this photo, okay, or drawing. And what you first notice, they got two drawings, by the way, two sets of drawings. One drawing is a lot of horses and carriages, fires, we're back to cavemen. Cave women, okay? And the other one's like these very futuristic drawings with solar panels and sail-powered cars and things like this. And then, so that was interesting, sort of people you thought, oh, once we're out of fossil fuels, it's just over. We're going to put all the computers away, go back to, you know, hunter and gatherers and stuff like this. Or we go to this futuristic path, but notice the date on it. It's 500 years away. They would have these projections that were really sort of unrealistic. You know, 500 years from now, we'll be using wind power. Well, Iowa is currently 28% powered by wind. It's not 500 years away. It's fairly immediate. So our conceived notions, and they just pulled people off the street, and just set a focus group and asked these questions. So who are we? A lot of you in the room know, but we basically work on STEM education, or basically clean energy education in all sorts of fields, solar, wind. But definitely got our start in wind, where we really geeked out on wind a lot. But definitely moving into solar and other spaces. And our goal is really just to help. We have like High Tech Kids is in the room. We partner with them to do stuff. We partner with the Science Museum in Minnesota. We partner with the Bakken. Lots of groups sort of, partner with us. We do a lot of training. This is a great shot of teachers watching a wind turbine tower being built at a plant in Minnesota. They're staring down the tube there. And we do, a lot of people don't know this, but most of our focus is on teacher training. Workshops where we build the capacity of teachers to implement things in the classroom at a high level. This is a picture just of one group. We've done 5 summers of Wind Senators, they're called, and these are our master trainers. They're in 27 states. There are now close to 92 of them all over the place, and they're really the people that get all the work done sort of in all the states we're in. And we sell stuff, but everybody just thinks we sell stuff, but it's actually one of the minor things we do. So what is the KidWin Challenge? Or the same thing as what is the Minnesota Renewable Energy Challenge? Some pictures here from the one we just did, too. Basically, it's just a way to get kids excited about wind energy through building things and then learning about wind power and presenting their, what they've learned to judges, to the community, and things like that. And you see lots of different pictures here. You get everything from, there's even a laser beam. Like, this was a contestant this year, like 3D printed blades, really high-end, crazy stuff, to like, kids using double bubble tubes and things like that. And the real goal is like, it is a challenge, like we do pick winners and stuff, but it's much more of a celebration of like learning about wind power, but then building something that works in the wind and does things. These are some great entries. This April last year, there was some great vertical axis stuff. I think all these pictures are actually from, except for that one is from ours. This one is the current grand champion in the United States for the best. He's out of Buffalo. He built he got a job at a wind company after they came up to him after and gave him an internship for the summer. Like, you need to come work with us. It was a pretty amazing device. Exactly. So there's 2 ways to participate. I'll get more into what participation is, but it used to be just like the in-person version where you'd come and you'd bring the turbine you built and you stick it in this wind tunnel that's 4 feet this way, 4 feet this way. You blow a lot of wind in it and you see how much power you produce. There's also components like in Minnesota with High Tech Kids, we do a really much more engaged version where the kids have to do, depending on what they do, they have to learn about careers or they have to site a wind turbine, figure out how to site a wind turbine at their school or a location. It sort of started very simple, like let's just build things and put them in the wind tunnel. But as it's grown, we sort of added these other components. This, as we all know, as teachers can be kind of, it's a lot of work to get your kids out to a full-day event and do that kind of stuff and build. So now we have a web version where what you see here is like kids just basically upload us some basic information. So a classroom teacher could do it in a class and in a say, 2-day time period. They could get this done and get it into the system, and then once a month we pick winners and send T-shirts and a prize and stuff like that. And if what we think is if they get really excited about this, they might actually come to this. It's sort of a feeder in some respects too. Why do we do it? There's lots of reasons we do it. As you see, sort of this is nationally this year probably about 3,000 kids nationwide have been involved. These are sort of the major points we're trying to hit. Basically get kids excited about renewables and wind. We want kids to build things, not design them in CAD and just think about them. They got to build, test, experiment is really important to us. Get girls and underrepresented populations involved in these fields. If these are the new fields coming up, and actually already in these fields you don't see much underrepresented populations and girls already, and these are what we consider the fields for the next 20 to 30 years. If we don't get them in now, we've got a problem. So it's sort of, we want to start off pretty straight with this. And actually, Cheryl, who's here from High Tech Kids, had some great data. I think we had 50% minority representation at the one we did here in Minnesota, and girls, it was almost 50% too. It was right along there, right?
I think we're actually under 50%.
Like 47 or maybe something like that, or 40, 45.
That was the St. Paul schools sent out a ton of teams.
Yeah. And the coaches were motivated to come out too from St. Paul.
They did a great job of recruiting those teams.
Yeah, no, some of the teams had all girls. It was fantastic. It was really great. And then, another big thing is we're just trying to build the capacity. Like, we want this can be an in-school program. It doesn't have to be out of school because we do have a full curriculum that sort of supports this as well, too. And then the other role is just connecting kids to mentors, and that's the thing that High Tech Kids is really teaching us about is how to build those partnerships with companies and get the kids connected and like at least give them a little bit of feedback. Like, how does this, how does this connect? So what is a challenge or how does it work? So the kids start with some basic stuff. Really, the only thing you need to attend a KidWin Challenge is that, just the generator. and it costs you all of $3. One of the things we want to do is keep the cost really low, as opposed to other robotics things, as a sort of a standoff to some of these other things. Really, the only thing you need to show up is that. And you could do, if you had that, then you can compete. And we tend to donate those for any programs we have, and things like that. And then you can use all sorts of stuff. Of course, we have kits, but you know, PVC pipe, gears, scrap wood, connects, Legos. We've seen kids using Legos. They reuse their Legos and stuff like that. But anything they can use, student creativity. They have to think for a while and build things, so that is a major component. And we see all types of turbines, actually. I mean, we've done, this year we did 25 in 16 states. So we've seen everything from really basic stuff to really, you know, advanced stuff. Add in some teamwork. The kids really have to work in teams. They have different things they have to, especially in Minnesota, where they've got all these different things they have to do, like get ready for a presentation to industry guys, get their turbine ready, do, you know, another thing. So they have to break the work up. And then they come and we ask them lots of questions. How did you build this? Why did you do that? What did you do there? What did you learn about wind power? What did you learn about energy in general? So, you know, there's a lot of, you know, they do have to sort of get ready for talking to people. And then this is a example rubric. It is a little bit different in Minnesota because we do add in some other components. But 40% is based on how much energy they produce in the turbine. 25% is sort of blade design, and 20% is reporter engineer's notebook. In Minnesota, we reduced some of the energy in the turbine design, and we add in a knowledge component where they did a siting project last year. Year before that, it was like a careers component, right? We did a careers component. So we sort of reduced some of those ratios and add in some more kind of more meaty kind of knowledge gain stuff. In some places, they just almost do like this part because they don't have enough time. Like in the classroom stuff, they say, I don't have enough time to do all this stuff. But in Minnesota, we sort of have the luxury of the time. There's that. Just a sample of, you know, kids submit all sorts of reports. How can we recycle our project? That's my favorite. So they stick them in a wind tunnel. This is one of our first wind tunnels we ever built many years ago. So kids are sticking in there. It was actually built by a team of high school wood shop guys. We gave them $1,000 to build us a portable tunnel. They designed it. They were part of an engineering curriculum, so they do the CAD design. They built the whole tunnel and everything. That was really cool. This is our current sort of tunnel. It's just big fans and a cage to keep things safe. And then we hook it up to some data monitoring systems where we measure voltage and current, get power. We do power over time, and get energy output. And that's a lot of things. There's a lot to learn in that space just for kids, like what is power, what is energy, what is voltage, what is current. So, you know, what I'm quickly going through here, actually there's a lot of rich space for kids in the classroom to be learning about all these concepts too. And building and testing a turbine is a really heavily iterative process. Like, yes, you can learn all the kind of theory, but it really requires you to build, test, build, test, build, test. Here's a challenge in Washington. You can see we get, you know, in some places we get lots of kids. These girls are like really scared that their turbine is going to fall apart in the tunnel because a lot of times they test in front of smaller fans and then they say, oh no, what's going to happen in the big tunnel? And so they're sort of in a panic. Is it going to stay together? This guy's, you know, he's blowing. We would joke, he's like, wish it would go faster. You know, this is a different tunnel we had from a long time ago. This is actually a challenge we did 3 years ago at Leonardo's, yeah, which was great. There may not be always smiles. This is one of the best photographs I've ever seen. They're not the best, but like their turbine just didn't work, and they were trying really hard. It was really depressing, but they sort of like learned from the process. I hope a little bit that it wasn't terrible, but I don't know whoever caught this picture, sort of just like they're all staring at the turbine like, please spin, please work, come on, go, 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 you know, and they worked really hard to kind of get it going. The happy story at the end is they did get it to work after this, but we didn't have, you know, I should have had the after shot. We do give out prizes. In some places we give out cash because we said nothing says good job like cold hard cash is my belief. So kids get a check to hold. We now let them take them home and they hang them on the wall. They think that's great. But you know, it's really great. And what I want to emphasize here is that what looks like sort of free time and play as they build these things is actually embedded with quite a bit of standards-based learning. What we're doing right now actually is going through the next generation science standards and aligning our curriculum to, because once again, there is a full curriculum suite of like 20 lessons in biology, in physics, in math, and other spaces that backs this up. And some people don't use, and that's fine, but you totally could use a subset of these lessons to sort of get your kids ready. In fact, for the knowledge component, if the kids actually did some of these, they'd come in really knowledgeable about wind power and things like that. But you know, everything from scientific process to inquiry to forces to simple machines, energy transformation, like all these are littered throughout next generation science standards. And as we realign our stuff throughout those standards, and actually even the new next generation works for us. In fact, next generation has in it stated in a number of places like a wind turbine, like, you know, as example of something. I mean, it's like it almost was like written by our staff in some of the places. I don't know if Minnesota's going to adopt next generation. That'll be the interesting thing. I think she sort of, what's her name, giving the talk today, sort of blew off that question about how are you going to squirt in more science when we got to do all the math and the reading, and we're already unhappy about where those scores are going, and you're going to add in, and then her answer is, we need to look at a longer school year. Apparently she hasn't been talking to teachers unions or anybody else about this, because that, you know, and then they use a statistic from Louisiana saying they're in school up, but there's no correlation to performance. You know, you're in school for 1,100 hours, but did you see Louisiana's scores? So let's understand that dynamic as well. I don't know, it's a total non-answer in some respects. That's just me on a soapbox for a minute. And it doesn't happen without lots of support. We have tons of companies that support us, and we have really great partners who help us execute, namely High Tech Kids are in the room, but in lots of states we have similar groups like High Tech Kids who allow us to sort of get this done. And you know, and actually we've learned a lot. High Tech Kids is probably one of our best partnerships. I've learned a lot about how to organize things and get kids out and do really cool things. So they are really, Cheryl and Vicki here, it's pretty amazing what they've taught us. So that was all. I sort of just, you know, that's my quick introduction to it. I don't know, once again, you guys all know everything already, so I don't know if you have any questions at all. But I would love to see David out again. He's fantastic. He's got a lot. I think we missed, I was supposed to come out to his school, and like, I wanted to see the school, number one, because I wanted to come see it and then help him a little bit with him. They went into vacation, and then he came back, and sort of, you know, we missed paths, but I fly, a lot of my interest in this, I fly a lot of model electric airplanes, and I fly a lot of model, like stuff like that, and so the aerospace component of the schools sounds pretty awesome. Yeah, no, it sounds great.
I have a question. About 10 years ago when I first came to Concord, the pre-K 4 site was a very open site.
Mm.
Unfortunately, now they've AT&T and some telephone company
Want to put a tower or satellites there.
And I mean, I actually thought, and I actually tried to pursue it a little bit, but when you're a teacher,
Yeah.
but I thought, you know, what a perfect spot for a wind turbine.
Or like a demonstration site.
We all need communication, but I thought, what a teaching tool.
There's a program that's really interesting called Wind for Schools that we're a big part of that is basically a support system for that. Yeah, and also, but to be honest, the person to go talk to, and I could totally get you in touch with her, is a woman out at Matamidi Middle and High School who they installed. She got the community and Excel to sort of invest in putting a turbine up, and we did a lot of training out there to the teachers so they would like. What we don't want to see is you put up a turbine out there, it becomes a glorified pinwheel. Like the kids look at it like, yay, it's spinning, but have no idea what it's doing and stuff like that. So, you know, so she got it, and then we went up there and helped them integrate a bunch of curriculum into the sciences up there in the technology. But no, there's examples for sure. It is. You're right to say, like, you know, as a teacher, and it is a lot of work, you know, because there's a lot of like solar is what they say. Solar is an electrical project that you sort of glue to the roof, but a wind turbine install is a mechanical and electrical because there's these foundations and structures and stuff like that. So it does involve like all your facilities people have to be like, yes, I'm really excited about this. And you know, I know of a couple hundred schools that have turbines installed, you know, in a lot of sites. So it does happen for sure. And I can definitely point you to resources on that. Yeah, SES. Dakota, they donated it, right? Yeah. And they have a cool monitoring system right in the school that, which I really actually think is one of the better ones I've seen that really tells the kids what's going on.
You didn't do a great job of pointing it out, but it's like, oh, look at that.
Or too busy running around. But I think the kids look at it. Like, I caught kids looking at it. Yeah.
They
Well,
do have an exhibit outside, too, that you can check out.
one of the things Asia and I are working on, Asia's another colleague of mine at Kuhn, is we want to like have kids design sculptures that are powered by the turbines or the solar panels. Because what happens is the turbine gets put up and then there's this data feed, and it's like sort of interesting, but kids are like, it's data, it's spit out. But what if your job was sort of take the electricity and every time the turbine spun, the sculpture did something? So it's an art project, but it's also connected to this device outside. So Asia and I have started to cook up some ideas on like, okay, what would that look like? And there'd be a motor of some kind that spun, so what could they do with that? Or a water pump, or a fountain, or something. Yeah, but it like keys you into like, oh, the solar panel is making electricity. The fountain is going, or the thing is spinning. Because the data, a lot of people like, the data is very exciting for the kids. Like, no, it's not really. Like, they could care less. Like, my idea of like kids looking at data, like, we don't care about the data. Like, but if the fountain was like sprouting off, okay, the turbine is spinning. So that's a project we're actually starting to work on. We love that. That's sort of it goes into that space for sure. But we want to, one of the big things is every year trying to find a new thing for the kids to get to. So let's say every year the art class does a new sculpture related to that, and it uses the electricity. There's some wiring, and it does involve getting your electricity people involved, but I think it's still a neat idea in a lot of respects. Uh-huh. Oh, yeah. It's like a big moving sculpture, basically. Is it wind-powered or electricity-powered, or is it kind of like... Yeah. Something like that. To build something that... And it's a quick identifier, like, oh, it's making electricity. I see that now, Cool. Very neat. Great. Well, thank you for being our guest here. Yeah, I want to get David. Tell David if he's still interested. I think I have some dollars. If he's motivated, we'd love to have him out in Portland. He'd be great. He just could tell from his energy that he'd be a great sort of mentor to many, not just his students, but other teachers. Interesting. I used to do, when I was a teacher, a lot with watersheds, like going out to stream ecology and collect bugs and, know what your watershed is like and all that stuff. Kids love that. Great. Thank you, guys. That was easy.